whereas the sorghum of my neighboring farmers dried out even before flowering. Nowadays, Mahatma Phule Agricultural University recommends a row-to-row spacing of 1 meter for non-irrigated post-monsoon sorghum. Another example is that of rain-fed cotton in Vidarbha. The best time of planting cotton is the first week of June, but because the monsoon starts in Vidarbha by the end of June, the cotton seed cannot be sown before the first week of July. I planted the seed of cotton in the first week of June into plastic bags filled with soil and watered them by hand. Once the rain started and the land was sufficiently moist, the seedlings were transplanted into the field. The transplanted cotton plants gave 80% more yield than the cotton raised from seed sown in July. This method is nowadays widely used by cotton farmers in Khandesh and Vidarbha. Another free input that plants receive from nature is light. Since everybody is aware of photosynthesis, I won't discuss it. I shall discuss other phenomena which are relatively unknown and on which I have personally worked. One of them is the effect of light on the development of plants. Plants generally produce flowers only on organs exposed to daylight. Whenever a plant is shaded, it stops the development of branches, flowers, and fruits and just grows tall in order to grow out of the shade. Under high population density, the plants shade each other and therefore instead of developing fruits, they just grow tall. The panicles of cereals are produced at the apex of the stem. This site is always exposed to the sun. Therefore, cereals can be planted under a high population density. However, maize, which bears its cobs below the leaf canopy, represents an exception. If the maize crop is planted too densely, the cob formation is suppressed. Some of the modern varieties of maize can be planted more densely because they have short leaves having an upright orientation. The dicotyledonous plants like cotton, sunflower, tomato, etc. cannot be planted as densely as the cereals because they bear their flowers and fruits below the canopy of leaves. But in spite of having pods that are borne below the leaf canopy, leguminous crops are planted almost as densely as cereals. I proposed the hypothesis that because the legumes fold their leaves in the late afternoon, they allow sunlight to illumine all parts of the plant. This light induces the development of flowers and fruits on all nodes, even when they are shaded throughout the day. I proved this hypothesis by conducting appropriate experiments. The fact that plants produce flowers and fruits only on those parts which receive light is demonstrated by trees that grow near a house wall. Such a tree produces its flowers and fruits on the side opposite to the wall. This example explains why crop rows should be oriented in the north-south direction. Plants in such rows are exposed in the forenoon to sunlight from the east and in the afternoon to light from the west. If the rows were to be in the east-west direction, the plants would receive light either on the southern side or on the northern side, depending upon the season. It is an interesting fact that weed seeds need light for germination, whereas the seeds of cultivated plants can germinate even in darkness. A Japanese scientist by the name of Fukuoka recommended that in a rice and wheat rotation, the rice should be harvested by removing only the top half of the plants. When seed of wheat is sown in the rice stubble, it germinates. but the weed seeds being shaded by the rice stubble do not. When the rice stubble is removed, the weed seeds are exposed to light, inducing them to germinate, but they are unable to compete with wheat, which has had an early start. Another phenomenon related to light is that of the day length, which varies according to seasons. Many of our local varieties of cotton, sesame, and sorghum, and most varieties of pigeon pea flower in October or November when the days have become short. Also, their fruits develop under short day conditions. This is a strategy by which these plants avoid their fruits and seeds from being attacked by insect pests. When the days are long, the insects multiply once every 3 weeks. But under short day conditions, many of them go into dormancy and remain dormant till the onset of monsoon. As a result, the insect attack on the crop is much severe during the period of fruit development. With that, we come to the topic of mixed cropping. In mixed cropping, two crop species are grown simultaneously in the same field. The seed of both the crops is sown with the onset of monsoon, but one of the two crops is late maturing. The plants having late maturity generally grow large in size. Therefore, they are planted at a wide row-to-row spacing. This allows a short duration crop to be grown in the intervening space. After the early maturing crop has been harvested, the late maturing crop grows to occupy the entire field, giving its full potential yield. The income from the early maturing crop is an extra bonus. If the field is divided into two halves and the two crops are planted separately as sole crops, one would get only half the yield from each crop. I cite here the example of a mixed crop of pearl millet and pigeon pea, that is bajra and arhar. Both the crops are sown simultaneously in the month of June or July. Pigeon pea, which takes about 6 to 7 months to mature, is planted in rows 180 centimeters apart. Pearl millet, which matures in about 90 days, occupies the space between the rows of pigeon pea. Actual experiments have shown that while pearl millet yields almost 80% of its potential yield, the pigeon pea gives its full normal yield. Also, sugarcane, a long duration crop, allows a number of short duration crops such as onion, potato, radish, groundnut, cabbage, early maturing maize, leafy vegetables, etc., to be grown as companion crops. While one gets the full yield from sugarcane, the income from the short duration companion crop is an extra bonus. I have also worked on natural pesticides. Farmers spend a lot of money on chemical pesticides. There exist in nature almost 100,000 species of insects which feed on plants. The number of organisms that cause plant diseases is even larger, but only a few species of insects and fungi are seen on any one plant species. Actually, all plants possess insecticides and fungicides of their own, which protect them from almost all the insects and pathogens. But in the course of evolution, some of the insect pests and pathogens developed resistance to the naturally occurring biocides in plants. Since the insecticides and fungicides produced by each plant species are unique, the insects and the fungal pathogens are both unique to each plant species. The fact that the caterpillar of the silkworm eat only mulberry leaves and not the leaves of any other plant is a good example of this phenomenon. It is theoretically possible to kill the insect pests of one plant by exposing them to an extract of another species of plants. The use of tobacco decoction and neem seed extract as insecticides is based on the same principle. But it should be noted that tobacco decoction would not kill the insects feeding on tobacco, and similarly, neem similarly, neem seed extract would not kill the insects feeding on neem. Armed with this knowledge, we can now search for local plants which can serve as source of insecticides. But before advocating their use as general pesticides, it would be necessary to establish their safety to humans and also to other beneficial living beings. These toxicological studies are very costly, and that is the main reason why the indigenous development of plant-based pesticides has come to naught. In response to an attack by fungal pathogens, plant cells generally synthesize chitinase enzyme. It kills the fungal pathogens by dissolving its cell wall, which is made of chitin. Chitin is also present in prawn shells, which are available as a waste product, which with units that export prawns. I could show in the case of tomato that application of prawn shell powder to the soil rendered the crop resistant to many fungal diseases. While we are on the topic of insecticides produced by plants, let me tell the audience that it was well known since 1950 that the roots of all plants exude biocides into the soil. They kill not only the bacteria but also fungi, protozoa, nematodes, and insect larvae. Almost 60% of the Ayurvedic formulations are based on roots. It was generally believed that the biocides produced by roots protected plants from pests and pathogens in the soil, but I argued that plants might also be using the biocides to kill and consume the microorganisms in the soil in order to get the necessary minerals. This assumption was supported by experiments in our laboratory, which showed that the population density of soil bacteria got depleted by about 75% when plants were raised in the soil for a period of just 40 days. Further support was provided by a water purification technology called the root zone technology. In this technology, domestic sewage is passed through a bed of soil having plants. This treatment removes almost all the bacteria from the sewage water. Armed with this knowledge, I showed that it was possible to grow crops by supplying them solely with bacteria. Application of any digestible organic material to the soil serves the soil bacteria as a carbon source, which induces them to proliferate. During proliferation, they take up minerals from the soil. Thus, by keeping a mixture of sugar and moist soil in a tank for a day, one can increase the number of bacteria in the soil, and this soil is then applied to a standing crop instead of a chemical fertilizer. Although the bacteria differ from soil to soil, all of them have the same minerals in their cytoplasm, so it is immaterial which bacteria are consumed by the plants. A seasonal crop is generally provided with 100 kilograms N, 50 kilograms K2O, and 50 kilograms P2O5 per hectare. As chemical fertilizers, this dose would cost about rupees 7,500. If one used the soil in one's own field and produced bacteria by adding biodegradable waste from one's own household or farm, it would cost nothing to feed the plants with bacteria. This would naturally raise the profit of the farmers. The fact that biocides in roots kill and consume not just the bacteria, but also insect larvae explains why the swarming locusts lay their eggs in the desert. Were they to lay their eggs in the soil having plants, the roots of the plants would kill and consume the larvae. Thank you. If there are any questions, I am ready to answer them.
Yeah, maybe Ashok, you can ask your question directly.
Yeah, surely. Uh, Sir, a very nice overview of the work and importance of agriculture. My question is generally the plants which are crop plants which are went through the process of domestication are highly susceptible. So I feel that something happened during the process of domestication that they are susceptible to the diseases as well as pests. So what is your opinion on this?
No, you are quite right. After all these, most of the substances that protect plants from insects and fungal diseases are phenolic compounds belonging to a group called tannins. The tannins impart uh, bitter or astringent taste to the plants. So when people selected plants as food, they naturally selected plants having low tannin content. And that's why they tasted better, but they became more susceptible to insects and diseases.
Any other questions?
Yeah, can I?
Yeah.
Yeah.
Please.
Dr. Karve, you said that mix sugar and sand and then you apply on the soil. Is it possible to apply sugar itself dissolved in water and water the plants?
Uh, well, we tried it, but what happens is that uh, the sugar serves the bacteria that are present in the soil as food, but the bacteria need the minerals also. So there is a competition between the plants and the bacteria for the minerals that are available in the soil. So that is why I recommend that the bacteria should be multiplied outside the field separately in a pot, and that soil in which the bacterial population has increased, that soil should be used as fertilizer or manure.
Okay. The other question is, you said sugar cane and tomato or potato together you grow mixed crop.
Yes.
Is there a list of things that one can do, because it is probably I'm just trying to learn. So in places where you don't have a lot of water, sugarcane growth may be difficult. So is there a combination of many other crops?
Yes, as I said, arhar has a deep root system, and uh, it takes about 6 to 7 months to mature. So you can plant arhar in wide rows, and between the rows of arhar, you can plant any other short duration crop. You can grow onion, you can grow vegetables, whatever you want. I gave the example of arhar and bajra, but any other crop can be planted as a short duration companion crop.
Okay. Okay. Thank you.
Any other questions?
Can I add for Krishnamurthy's question?
Yeah.
Krishna, if you see our traditional practices, we always have a combination the way we have in food, like cereals and legumes. So same thing, like for example, I came from a farmer's family. So we used to put even mung bean, moth bean in the pearl millet, that is bajra, or even in the jawar we used to grow. So intercropping is very traditional way of doing it. So there are a lot of combinations are available. That's what I mean. So in fact, there's a logic, because these legumes are nitrogen fixing organisms, whereas cereals are not that effective. So that combination also is very good for the soil conditioning and so on.
Okay.
Yes, if both the companion crops mature at the same time, then the advantage of mixed cropping is mainly a buffering action. So that in case one of the two companion crops is destroyed by pests or drought or over irrigation or whatever it may be, at least there is the other crop which gives the farmer some yield. But this particular thing that you said, that the legumes fix nitrogen, well, they fix it for themselves and they don't fix it in order to give it to somebody else. So this is a fallacy where it has come even in the textbooks that the blue-green algae fix nitrogen and that nitrogen is given to rice. They don't fix it for giving it to rice. The rice actually kills the blue-green algae because they are bacteria and takes all the nitrogen from their cells.
Yeah, there is a question from one Archana. What she's asking is whether intercropping practice for a long time, will it degrade the soil?
No, soil has all the minerals that plants need. You know, if you go anywhere in the world, you will find green, healthy plants growing. So that is how I started my research, that I realized that apart from the water soluble fertilizers which the farmers are using, there must be a mechanism in nature which makes the soil minerals available to plants. And I found this mechanism to be that the plants kill the bacteria and feed on them in order to get their minerals. That is the natural thing.
Okay. So there are no other questions, but I have a small
No,
doubt.
just let me
Please,
complete.
go ahead.
What happens is this naturally occurring soil minerals have very low water solubility. That is why plants find it difficult to take it up. But the bacteria can take them up. And what actually happens is this water in the soil is called capillary water because it is held in the capillaries between the soil particles. Now, if a single molecule, this represents a saturated solution because of the extremely low solubility. The solution may have a concentration of say 5 ppm, but even if a single molecule is taken by a bacterium, that molecule is replaced from the undissolved minerals, the pool of undissolved minerals in the soil. That is why I said that soil has all the chemicals that plants need, only they are not in a form which is available to plants.
Okay, thank you. Now, I just want a small clarification, sir. Is a natural farming a part of organic farming or is it a substitute?
Well, there's a slight difference between organic farming and natural farming. In organic farming, you use, about 200 years ago, Justus von Liebig in Germany first discovered that plants have minerals, and he found what minerals they are and what mineral plays which role and all that. Since then, everybody started applying water soluble chemicals to the soil so that the plants could get them. That was the start of the chemical fertilizers. Since then, a sort of a misunderstanding has grown among all scientists, and that is, the organic farmers say they apply organic manures and not fertilizers. But they analyze the organic manures and find that the amount of minerals in the organic manure is so little, even our textbooks, they recommend that if you want to apply compost to a sorghum crop, you have to apply 100 bullock cart loads per acre. That means 40 tons per acre has to be applied to 1 acre of. So that the transport cost itself is so high that the farmers prefer to use chemical fertilizers. So I have shown now for the first time that the plants actually feed on the bacteria, and that is their source of minerals. They don't take the minerals from the soil at all.
Thank you very much. So thank you, sir. There are no other questions. We have profusely thank Dr. Karve I mean, yeah, just, thank you very much for taking the time and giving a wonderful talk. Let us give him a big hand. So next we invite Krishnamurthy from National Chemical Laboratory, to be a young and very active experimental chemist. I would treat as an experimental chemist rather than, calling him as a physical or inorganic or organic experimental chemist, a very distinguished young scientist. So I would like to hear him. I think this work is different from normally what you do, right? This is your hobby, okay, right? I think I guess so. So please, go ahead.
Yeah.
Krishnamurthy, you can start.
Yeah. Can you see my screen?
Yes.
Yeah. Thank you, Professor Madhura, for a kind introduction. I also thank the organizer. Okay, I am talking on this topic because of a misunderstanding. Okay, I come from many of my relatives are farmers, so I am usually keen on listening to farm related or agriculture related stuff. So when Dr. Karve wanted to give a talk in the mini symposium, I wanted to listen. So I requested Dr. Gopi, but he thought that I want to give a talk on agriculture. So yeah, eventually I was shocked when in the previous meeting it was decided that I will speak on agriculture. And then the next shock came when the schedule came. Yeah, when the schedule says I'm supposed to speak from 6:30 to 7:55, so 1.5 hours. So I was again shocked, but I think it's a 20 minutes talk. So I will talk about few things that I read, which may be of interest to you, and I'm hoping that to speak in such a way that you all like it. So early humans were predominantly non-vegetarian, which I think many of you are aware because they didn't have weapon. Usually they used to eat what is left over by, let's say, a lion killed a deer and then what was left over. That's what they were eating. And they may have eaten fruits and trees, fruits from trees and few things like that. Largely they slept on treetop because there was no fire. So for safety, they used to sleep on top of trees. But there are now evidence that it is, so they started using bed earlier than what it was thought several years ago. Now, so this is some of the timelines. The Homo habilis were the first to use stone tools. Homo erectus was the first to control fire, and Neanderthal. So Neander is a valley in Germany. So valley is Thal in German. So that's Neanderthal, and they had an overlap with Homo sapiens over a period of over a short period, right? So. And so it turns out that the flint that was found, which is 3.3 million years ago, indicates that the human being were using stone tools than we initially thought. So they all can be clubbed into one category of hunters and gatherers. So there were no permanent settlement, that all these people can be classified into that category. Now, a Neolithic Revolution is the one that started about 11,000 years ago. So this is the region where the agriculture started. It is largely it is known as Fertile Crescent, this is region. So it's basically Nile, Euphrates, and Tigris, these three rivers and river banks where the agriculture started, right? So this is the period where deforestation happened, domestication of animals, irrigation, pottery, and rectangular houses, everything started, right? So if you look at the oldest sculpture, the believed to be a sculpture is of a cow, which is the starting point of the domestication of animals. I was looking for that picture. I found it in a documentary, but I couldn't catch hold of that statue. But you can easily Google the 4 cows that is in the museum, Egypt museum, you can easily find. So the domestication started during that period. Wheat, barley, peas were grown during that period. Rice cultivation started about 6,000 years ago. So until that time, was necessity. When they were hunters and gatherers, it was uncertain. Once the agriculture starts, there is certain amount of surety that you get a food. And then they started making food for pleasure. For example, beer recipe was found in Iraq in a clay tablet, which is 5,800 years old poem. There, the beer recipe is found. And the beer residues were found in Iran about 5,400 years ago. So that is where once the agriculture starts, you start making food that can be converted into pleasure. Okay, that is what was happening, which is about 6,000 years ago. Now, so women were the first early, they were the brewers, and in fact, and God's beer. There is no God. It was brewers, right? So the pyramid builders were supplied 4 to 5 liters of beer and bread. Okay, it turned out that that's their salary. So the pyramids were not built by slaves. It was built by paid labor, and the payment was in beer. Okay, at that point, beer was considered to be the first salary. So then around the same time, the medicines also starts having beer in it. So there are hundreds of medicines which had beer in the beer as one of the ingredients. Or if there is a medicine, they say take it with the beer. Like now, if you go to Ayurvedic doctor, they will tell you, usually, at least the Ayurvedic doctors I met, they will say take this medicine with honey and lemon, like that. So beer was one of them. And so the beer were usually brewed using wheat and barley. For gods and kings, they used to make it with the dates and honey. Okay, so in a banquet, the quality of the banquet or the success of the banquet is decided based on intoxication and the amount of beer consumed. Okay, so in Egypt, Mesopotamia, these are a region where the agriculture brought in a food that is for pleasure, and it was very widely used. All of you know Tutankhamun, the child king, whose tomb has beer brewed from honey. Okay, so he had honey beer in his tomb. And one more information that I want to tell. So here is his mosque, which had pearls in the mosque, in the golden mosque. These are pearls. These pearls are from India. It's about 3,500 years ago. So the beer was also offered to gods in Egypt. Okay, so to God they offer beef, bread, and cake. To the god, the priest offer it, and then obviously gods don't eat any of the offerings. It's the priest do, right? The priest take all these offerings to home and they eat it, and it's a kind of a deadly combination, right? Carbohydrate, fat, alcohol, salt, everything that was offered to God was eaten by the priest, and they had heart attacks. So about 40 mummies were studied by University of Manchester to find out the reason for the death, and it was found out that all of them had blocked arteries. Okay, so when the human being were largely were hunters and gatherers, probably they had very little carbohydrates in it. The moment agriculture comes in, your carb content increases, and that I think complicates. So the priests were the one, they were eating everything, but the Egyptian population were found to be largely vegetarian diet. They were eating vegetarian diet because agriculture was sufficient, and they had food, everything. Similarly, it was interesting that Nile being there, and there were fishing carvings and all, but it seems the carbon dating studies indicate that they probably didn't eat much of fish. So agriculture was the one that also they started studying the timing. The picture that you see here is one of the oldest clocks. It doesn't give you the time like hour and minutes. It gives you the season. Okay, so the season was studied to sow the seeds and start the agriculture. So this is the early part of it, and then it became the economy, right? So tea farming. So China was the largest producer of tea, and their economy largely dependent on tea export. Okay, I'll give you the data. So this is one of the old pictures. So tea initially was drunk for medicinal purposes, and then people started drinking it for pleasure, right? So a lot of people started drinking tea, and tea tasting became a favorite pastime activity, right? So in Europe, you see the wine tasting, like similar to wine tasting, there was tea tasting in China. So by 1600, Europe started importing large quantities of tea from China, and particularly British people loved tea, and the demand was very huge. So now if you look at what China did, China was producing about 250,000 tons of tea, and 53% was exported. So they kept it 47% for them. So if you look at the total export, 62% of China's export was tea. The remaining 38% were silk, porcelain, and glass. So 62% of their export was tea. Okay, so one of the agriculture income, and their economy was largely that became so that helped them to become an economic force. So then came the East India Trading Company, right? So Britain conquered India and started cultivating opium, right? So in India, what British did is they cultivated opium, and they were giving that to China. So British gave China the opium and took tea. So there was an exchange of that's a trade. In the trade, there was exchange of two agriculture produce. Now there is a problem. So Chinese people were addicted to opium, and a lot of people died. That's called Opium Epidemic. Okay, so because a lot of people were dying, so the Chinese emperor said British to pay in silver for tea. Right? You cannot give us opium and take tea. You please give us silver and take tea for that. British immediately agreed because the British people were addicted to tea. Right? So now the demand was so high that British could not say that no, we will not give you silver and we don't want tea. That cannot be done because the British people were addicted to tea. Obviously, exporting silver is untenable. So what East India Trading Company did was they were smuggling opium to China and access the Chinese tea. So the only Chinese port that was accessible to foreign trade was Canton Port. So Canton Port had a opium warehouse that the opium was, grown in India, was exported, smuggled to China in the Canton Port. Okay, now this has two problems. Obviously, it's an illegal trade affecting the economy of China, as well as the opium epidemic didn't end because there is a large amount of opium still being smuggled in. So the Chinese emperor ordered to raid the Canton Port and confiscate the opium. So I had the painting of it, but then because of space, I didn't put it. So the whole warehouse was, confiscated by the Chinese forces. Now, obviously, that's not very nice for British because British need tea and they had to find a way. And that's where there was a war. Okay, it's called the Opium War. And in that war, obviously, in that time, if you look at British won almost all the wars. Similarly, this war also, then came the Treaty of Nanjing. So Chinese paid indemnity and it opened up 5 ports. Okay, so earlier, only Canton Port was accessible for foreign trade, but China had to open up 5 ports, and Hong Kong became colonial country as part of the Nanjing Treaty. Okay, so it's one of the agriculture produce was a reason, not the primary reason probably, but was one of the reasons to make Hong Kong a colonial region, right? Then that's not enough. So British were thinking ahead. So they decided that they're going to smuggle tea seeds. Okay, so Robert Fortune was a botanist from UK. He basically from a poor background, but learned a lot by working in the farms. And he was tasked to smuggle tea plants, seeds, seedlings, everything. At that time, his salary was around $600 a year. It was a good deal, and he will have a share also in the tea trade. If he succeeds in smuggling tea plants and tea seedlings, they will be grown in India because the weather is conducive to grow that. So India, unfortunately, became part of this, immoral activity, in my opinion. So so Fortune cut his hairs and dressed like Chinese. I thought Chinese were naive when I read about this history. So when I look at this painting, he doesn't look like Chinese to me, even if he cuts and puts a dress. But he pretended that he's a Chinese, and he actually succeeded in collecting 13,000 tea plants, 10,000 seeds, farming and processing tools, everything, and he shipped to India. Okay, it came to Kolkata port. And by the time it came to Kolkata port, all these tea seedlings that he collected were dead. Okay, but then he didn't give up. Okay, he continued. Fortune continued to collect, and eventually he could plant 20,000 tea seedlings in Darjeeling. Maybe we are drinking the from where it grew up. So because now India is growing a lot of these tea plants, and tea import was not necessary for Britain from China, their tea production, China's tea production fell drastically, right? And once British raided China, Dutch and Americans also raided and took tea all over the world. That's how one of the agriculture produce spread across the world. It took 170 years for the Chinese to regain the world's largest tea producer tag, right? Eventually, they became the largest tea producer, but for over a period of a century, the Robert Fortune brought misfortune to Chinese. Okay, so we also work on tea. I think I spoke about my work on how we use tea to produce soup. In the previous Humboldt colleague. So these are some of the references that we continue to work on, that tea extracts to make scientific advances. Rubbers, this is another interesting story. This is another agriculture produce. So rubber balls were used in Mayan civilization. So these kids used to play with rubber balls. So this was made by, basically, there were trees in the South American countries where these white liquid oozes out, that was mixed with the juice that they take from a climber called the Morning Glory vines, and they mix it and they can make the rubber balls. They used to play, and there were games where the losing team were beheaded. Okay, that is what was happening. When the British went, they found the ball there, and obviously, British cannot resist. When they see something interesting, they will take it back to Britain, right? That's why Dr. Shashi Tharoor called the British Museum as Chor Bazaar, right? So I think he made sense. So now Joseph Priestley, the discoverer of oxygen, was the person who proposed the name rubber, and Michael Faraday, probably one of the finest scientists to work on this earth, predicted the empirical formula of the component of the rubber. Of course, Charles Williams distilled and named it isoprene. He also wrote, so Michael Faraday interestingly wrote in his notebook that he heated rubber with sulfur. Okay, that eventually is your vulcanization that was later credited to Charles Goodyear. Several people claimed that they did the vulcanization, but the final court ruling is in favor of Charles Goodyear. So Goodyear's the Goodyear tires. So Charles Goodyear is credited for vulcanization, but of course, tire alone, the rubber alone, was not the primary reason for its success. The pneumatic tires played a definitive role in the success of these tires, right? So Robert Thomson was the first to patent, but he didn't find its application at that time. John Dunlop's work on pneumatic tires was the one that led to a boom. So now you can always question whether the internal combustion engine is important or the tires. Now, based on Tesla's car, you can probably argue that tire is most important than the internal combustion engine. Of course, you can always debate, but if tires are not there, obviously you are not going to move. You may have a fast engine, but the tires are absolutely essential to move fast. Okay. Now, in the World War, it had a great impact, right? In World War II, so Blitzkrieg, all of us know, Blitzkrieg is the rapid advance of German forces. So when I read about Blitzkrieg, I thought they were all mechanized vehicles, but it turned out, when I dig out the information, it turned out 80 infantries attacked France, but only 7 of them were mechanized, but all other 73 were horses and walking. They used a medicine, I forgot the name, I was trying to find out, I forgot to add it. So the German soldier used to take a tablet which allowed them to fight 3 days and 3 nights continuous, right? So they almost 70 hours they used to fight. There was a medicine that was used for that. So see, at that time, the natural rubber was accessible to both Axis and Allied forces somewhat equally, right? Japan had a good control in Asia. Britain had also a large amount of Asian countries like India, Sri Lanka, Malaysia, the rubber producing nations, right? But what Hitler was largely using the rubber was for his flights. Luftwaffe was there. Hermann Göring was leading the Luftwaffe, and in fact, they were using the Luftwaffe to conquer nations. If you look at the Austria, when they conquered, they just the Luftwaffe fly over Austria. No shot was fired. Austria surrendered, and Hitler announced the annexation. Right. So probably he was largely using the rubber for his aircrafts than the mechanized road vehicles. But around the same time, US said that no, we can't rely on natural rubber. We must produce synthetic rubber. Although isoprene was polymerized in 1909 by Fritz Hoffmann in BASF in Germany, there were several others. There were Russians who were able to polymerize and all. But eventually, it was Waldo Siemens' work that allowed to mass produce rubber. So it was basically one of the agriculture produce was replaced by a synthetic material. So eventually by 1944, US was producing double the amount of natural rubber produced across the globe, right? So the other approach that the Allied forces used to defeat Germans was to destroy the tire factories, okay? So one is you produce synthetic rubber so that you don't rely on natural rubber. Number two, destroy the tire factories of German forces so that they cannot move fast. So there were these, I have listed few tire factories which were bombarded by Royal Air Force of UK and US Air Force, both in Italy and Germany. So they've destroyed several tire factories. Now, this is how basically synthetic rubber kind of reproduce one of the very important agriculture produce, that is a natural rubber. So the British habits, right? So Amazon forest was the sole source of rubber, and Brazil prohibited rubber export because to control the price, right? They were controlling the price. Here comes another kind of a fortune kind of a person. His name is Henry Wickham. He was actually in the South America. See, you know that Humboldt was in South America. Like so many Europeans were in South America as a tourist or explorer and all. So Henry Wickham was also in South America. Then he was commissioned to steal rubber seeds. Like Robert Fortune was hired to smuggle out tea seeds, right? So he collected 70,000 seeds as academic specimen. Like he didn't have to pretend like Fortune, but he can say that I am collecting academic specimen, although it's a lie, because in the Brazilian parlance, dead animal or a plant can be a academic specimen. Yeah, viable seed cannot be academic specimen, but a British guy told them that, you know, these are academic specimens. So he brought 70,000 seeds to Royal Botanic Garden in London. 2,700 seeds germinated. And then from there, they dispatched those seeds and seedlings to Ceylon and Malaya, right? So they were under British control. So that weather is better, right? So they transported them. So also, this is what British are, right? I have written as people migrated, but actually they were shipped largely from Tamil Nadu to Ceylon to work in the rubber and tea plantations in Ceylon. Okay, so it's economically viable because it was planned and it was organized. So Brazil, it was still in the Amazon forest, not easily accessible, and it was more like a natural farming. This is a new technology that was used. So now this is kind of funny. So Wickham was knighted for services in connection with the rubber plantation industry in the forest. It was smuggling and it was an illegal trade, but then he was knighted. So Usually, if you notice, I don't use smileys in my talk, but I just wanted to use it. Okay, thank you. I'll be happy to answer.
Thank you very much. So, any questions?
Maybe you can unshare the presentation, Krishnamurthy.
Yeah.
Krishnamurthy, can I ask one question?
Yeah, I'm glad that I heard that misunderstanding. So we had a good talk actually.
Okay,
Ashok, go ahead. Yeah.
Yeah, so Krishnamurthy,
yeah.
I felt that humans are frugivorous animals by their the physiology and the digestive system. They're not like non-vegetarians, like fruit eating or maybe plant part eating animals.
What is in what context you are saying this?
No, so the early humans.
You said they're non-vegetarians, no? So he wants to contest.
No. It's like just I'm saying that I was reading some time back. As far as I understand this, we were Homo sapiens were like more of a frugivorous, fruit eating animal.
So see, the whole paleo diet is based on the theory that early human were largely non-vegetarian. So that is why I put they also eat fruits, because I think the more and more data that people collect and more research goes in, I think new information are coming. See, the early flint was considered to be 3 lakh years old only, but the recent one says 3.3 million years old. So I think these are going to change with more research and more technology that we use to study these materials.
May I intervene?
Yeah.
If you look at the dentition, that means the teeth of humans, they are meant for herbivory. The typical carnivores have canines which are very big, and humans don't have that. They had to cook the meat so that with their teeth they could eat it. So I think basically they were, because the animals run away or you have to fight to kill them. Plants were there, they were standing in one place, they could easily pluck the trees, they could uproot them, they could eat the leaves. So
to go with Professor Karve, because I have also read, or I'm talking in terms of in a conference which is related to origin of life and other things and all, and they were also saying that humans are evolved to eat vegetables and other things. They are herbivorous, right?
Yeah.
So they have been evolved for that, and of course as Professor Karve said, the configuration of the teeth and other things and all. But then we evolved, but then we started to eat whatever was possible after sometimes, right? But then the early man or something like that. I don't know. I'm not saying that based on this could change over a period of time, as you said. Things could be different. The understanding could be totally different once we have more and more evidence and other things and all, right? But then I don't know.
Yeah. So this is, as it said. See, the flint is a classic example, right? It's a very simple and 3 lakh and 3.3 million years is a huge.
Yeah. No, that's what I'm saying. Yeah, and the flint also, the Flintstones, the cartoon, that is how the stone is coming from, I think. Yeah. I have one more question, Krishnamurthy. Your slide, you said one of the timeline was that they started to have agriculture or something like that 6,000 years ago or something like that. You said something, and then the beer manufacturing or beer brewing was 5,800. Within 200 years we evolved and then started to make beer. No, it's good. I'm not saying it's bad, but then 200, not bad actually.
Rice was 6,000 years old. That's a field in China. Yeah. So that
Yeah.
is what I was impressed that people were keen on
6,000 years and then 5,800 years.
Yeah. So they feel that it could be even older. See, this is based on a clay tablet which is available in Iraq and a beer residue in Iran. But the belief is that if they can document it at that time, probably people were using it little even earlier. So if you go back in 11,000 years ago, the agriculture, the proper cultivation started, irrigation, everything, and maybe in 1,000 years they actually started making beer and wine.
I'm just curious with the numbers. That is all.
Yeah.
Okay, thank you very much.
Yeah, just one comment. That drug what is given to soldiers is methamphetamine called Pervitin.
Pervitin, right?
MDA.
Yeah. I think we can close here actually, and Professor Madhura.
Thank you very much, Krishnamurthy, for a very nice talk. Because to prepare these slides and to take all this information takes a lot of time, I know. So you spend a lot of time. Thank you very much for doing this. So now we invite
Professor Rao. Can I just intervene a slide?
Sure.
There were some technical issues with the YouTube live streaming, so we had to stop. I have messaged it in our group also. So if you are, we have shared the new YouTube link. So if you are sharing with your students and all those things, you can forward that message. It is in our group, WhatsApp group.
Yeah, thank you very much. So now we go to the next talk by Ashok Giri. Yes.
No. Rajiv Kumar.
Who? Next is from who?
Myself, Rajiv.
Rajiv, sorry. I missed it. Okay. Next is Rajiv Kumar. He's going to speak on a very interesting topic. On one side, we are seeing a TV where Deepika Padukone and all those fellows are being called. And he's talking about all the... I think it's very nice to hear. Thank you very much. Come go ahead, Rajiv.
Okay. Thank you, Dr. Rao. See, this is a topic which has been in my mind for many decades.
Yeah, very good.
And I have been, this is also my hobby, not the research work, as the Gopi must be knowing very well. Now, I have written around a very big chapter, around 10,000 words and few things very recently submitted, and it is in the press for a book chapter. Now, this is basically, recently it has come. Now, I just want to say, this is the outline of my talk. I'm going to talk about something about the brief history and some sort of about basic what is the legal status and all those things, and then industrial applications, particularly for the legal cannabis. There will be a difference between the legal cannabis and non-legal cannabis, as per the NDPS and as per also the single drug convention, international. And then I will go for the medicinal applications, research and commercial trends, and you will be surprised to see, and I was surprised, and then of course the summary and conclusions, and there are some backup slides if there are question answers more on the technical part, then I can discuss that. Now, coming to the cannabis plant, the minimum time what it was told is at least 8,000 years before. That is the documented evidence that people in our Vedas, it is still perhaps I don't want to discuss on the dates, but this is what it is documented. In the 6,000 BCE, means 8,000 years. It is one of the fastest growing plants on earth. One of them. Whereas the bamboo can compete with this. All parts of the plants, like roots, mainly for the medicines, and leaves, as Dr. Karve has been telling, leaves, flowers, seeds. All these things are consumed completely. The treasure trove of phytochemicals, it contains almost 450 to 500 phytochemicals, including cannabinoids, terpenoids, and many compounds. Very rich source of the cellulosic material, which is woody and fibrous, and used for making bioplastics and concrete-like materials. The biggest use for this cannabis was also in the paper making. The first paper on earth was produced through the fibers from the cannabis. Cloth also. And many people were knowing that this the ship industry using this cannabis ropes, cannabis cloths for selling. the fiber is the major crop at that time. Ancient Indian texts like Atharvaveda, Sustra Samhita, and I have downloaded, by the way, just to see myself. They have considered it as very venerable, very gifted by the gods, and it is also known as Bhang and Vijaya. Now, new uses are being discovered and reclaiming soil fertility. I was amazed to see that Japan is cultivating it in a large way for removing the nuclear toxicity in the soil. It is a remediation also. Now, cannabis has basically three different, the cannabis is a genus from the Cannabiceae, and it has three sticks of the genus. Cannabis sativa, which you must be knowing, it is also popularly known as marijuana or marijuana. And then there is an indica, cannabis indica, which is basically in the Himalayan region. And you can see the difference. This is a tall, very tall, around 15 feet, 16 feet, 18 feet high. The sativa and the indica is basically the broad leaves, very bushy, but it grows up to say 6 to 7 feet. And then this is ruderalis, which is basically grown wild, and it is not seasonal. All these things that you can read downwards. However, the basic difference is that these sativa and indica are psychoactive. Ruderalis is almost nothing, near zero. And it is used with the cattle feed, and it grows widely everywhere. In the north, the moment you are even in my fields, on the side where the water is flowing around, it grows. And the people, this cattle feed is used for that. Next one is basically, I just want to make a difference between hemp and marijuana. Hemp is basically where the tetrahydrocannabinol, the basic psychoactive component of this cannabis, is less than 0.3% in USA and 0.5% in India, legally talking. Anything, and then no difference otherwise. And basically, male plant has got that type of ability. And it is harvested for the industrial uses and for the very derived products. We will come back to that. Marijuana is basically a seasonal one and contains much more than the 0.3. Basically, it is around 3 to 4%, 6%, 7% in the palm, but also it can grow up to the content of up to 16, 17, 18% by hybridization and many more technology. It is intoxicating, side effects, but we talk about the THC content and all these drugs, ganja and all of this comes from this one. Recently legalized in 27 to 30 states in America for medicinal and recreational purposes. Also legalized in India in 2018, by the way. And IIM, our friend already, IIM has, Jammu Kashmir has been given a license, which will come later stage. Now, what is the legal status? Because this is very, very critical to know for most of the people. Well, Indian Hemp Commission was established by the Britishers in 1894-95. And it has got 2,500 pages report. And I have downloaded it. It's easily available on archive.com. And there are commentaries on that one. The basic purpose was that this was the biggest, third largest crop in the country by that time, for ages. And it was also consumed by all strata of the societies. So they realized that this is a very good opportunity for the money spinning. Now, as Krishnamurti said, that the Britishers, opium, but it was not only opium, it was basically ganja and charas, which was also considered as a very similar poppy and the cannabis plant. They are basically in the similar region. However, cannabis was basically, they realized that there are two aspects of it. And people in India, it's culturally in every state they are using. But they wanted to have the kill the Indian medical system, which was very, very popular at that time, and still, because they wanted to have an allopathy. Now, allopathy has got, as you know, the basis of alcohol as a base. Similarly, in all Ayurvedic preparations and most of the Ayurvedic preparations, the cannabis, the ganja or the bhang are the basic ingredients as the base. And now they wanted to also promote the alcohol. So that is where they thought whether this can be banned or can be taxed. The purpose was they can get money from this one, and that is what the basic aim. Now, in NDPS, which we hear a lot nowadays on the TV, NDPS defines cannabis on the very third article, sub-article. And what is that it is, what is cannabis? It's a charas, hashish, that is the separated resin in whatever form, separated from the plant. It is resin which is separated from the cannabis plant. Or the ganja. Ganja is a fruit, flowering or a fruiting part. They have higher content of the THC, around 20 plus. And in that case, and any mixture of there, that is what the total NDPS talks about cannabis. However, in the cannabis definition, the leaves and seeds are excluded. And leaves and seeds are traditionally called bhang or bhanga. And many, bantai also, so many colloquial terminology for this one. And that is where it is not banned. In the federal law of the country, it is basically only the charas and ganja are criminalized. They are criminal. You can have, and then there are so many articles that how much you can have, but bhang federally is not banned. It is excisable, just like alcohol. You can have in north 4 or 5 states like Uttar Pradesh, Madhya Pradesh, Rajasthan, now Gujarat, Bihar, Himachal Pradesh, Uttarakhand. They all have the legal shops, government licensed shops for the bhang. And that is where it is so popular in Holi or otherwise also. The community which I come from is a very common. They take it very, it is all leaves which contain very less THC and more medicinal advantages. Now, as I told, CSIR IIM has got the license from a Canadian company in collaboration with. Similarly, now 30 USA, Canada, a few European countries and Netherlands have legalized recreational purpose also. So it is a recreational purpose as well as medicinal purpose. And of course, industrial purposes anyway. Now I'm talking about the industrial uses, a snapshot. You can see, and this is not what is, it is amazing. This plant has perhaps the only plant which has got so much to offer to the human beings that every plant is used. Now this particular thing, if you can say, the basic thing I will simply put here. You see, it is the superfood is the seed. In the Himalayan regions, those who are the sadhus and ecstatists, they simply take a bowl full of seeds, roast it and take, and they don't need anything else except water. For them, that is good enough food, and they can survive the whole day for that one. It is just like, and it is very much rich in the omega-3, 6, perhaps much better than the quinoa. And next one, you can see it is a food. It also gets the proteinous part also, and flour. People were making atta from this one. Next one is a paper making, as I told, is the first time, and paper is still the very common one, which can be done. Bamboo, since it is banned cultivation, that's why it was killed. That was the basic purpose, to kill cotton and cannabis, because the Britishers wanted to kill the economy and take the whole thing, as everyone knows. Next comes the textile. Of course, when the fiber is there, it is a textile. That's what the basic purpose was. And I will discuss in the next it is a comparison with the cotton. Now comes even the molded plastics. Now this is also recent use. Molded plastics, it can be combined with many things. And presently, there is a designer clothes are made because of this hemp. There is a complete showrooms on the hemp fibers in the US. And in India, also in Gujarat, there is a company called Hemp Fibers, Hemp Cloths. Now coming to, you see on the right hand side of your screen, you can see the comparison with the cotton and cannabis. Cannabis hardly needs any pesticides because no pest can attack it. It is so natural, it has adapted to the nature that it is widely used. It hardly needs any attention. It does not need much fertilizer because it has got intrinsic capability to kill the bacteria, what Dr. Karve was telling, because of the so much of and the roots are very much capable of killing the bacteria. Now, you have the only thing the bacteria has to be, and it also grows deep rooted, and that's why it holds water. Now, the next one is also, you can see the warmth. It is 300 to 400 times more warmer. That's why in the north regions in China, this is not which is being used even in the Central Asia. And also, it has almost 4 times more water absorbing capacity. And that is where it contains. And similarly, the strength of the fiber is 3 times more than the cotton. All these, the only problem is initially it was coarse, but now with the new spinning things, it is made very soft also and combined with the other fibers. Now, this is the general, I'm giving a snapshot of hemp industry applications, which are also modern uses apart from these one, and every part of this plant is being used. Agriculture benefits, it can be soil remediation, soil improvement. Anyway, you simply grow it in the wild and its soil improves. The modern things are many things. I don't want to spend too much time on this one, but purpose of this slide is that it is very much industrially used if it is cultivated freely. Only problem is that it is ganja and other parts also coming from the other piece, so that is being, but now the whole world is going towards the legalization is getting intensified with each passing day in the world. Just last week only, Pakistan has legalized for the industrial applications. India has legalized in 2018 anyway. Now, coming to the chemistry, what does it make it psychotropic? There are 3 types of cannabinoids. One is the phytocannabinoid, we can say, that is where the 2 main cannabinoids. You might have heard so much so about the CBD oil nowadays on the TV. So it is basically a tetrahydrocannabinol. The structure is given on the right hand side. And you see the difference between tetrahydrocannabinol and CBD, or cannabidiol. So little, they are functional isomers basically. It's only one is having an etheric linkage and a close ring. The other one is having only an alcohol and a double bond. They all are same, they are isomers, but they have a very different problem. CBD is practically non-psychotropic. It does not give you high at all. THC is highly psychotropic. This is the difference, and it is the potency of any these the material is the CBD THC CBD ratio. If they are in the 1.1 to 1.0 ratio, they are best for the medicine. Now, synthetic cannabinoids are also being developed by the actually Israeli scientists have been doing this much better. They have been doing it faster. And the first time this impetus for the research came in 1964 when THC was isolated. And they found that this is the psychotropic material. Since they found that this is the psychotropic material, there must be an endocannabinoid receptor also. So, and then they synthesized very similar to that. You can see the very similar material is called HU210. HU is for the Hebrew University. Endocannabinoids, when there is a cannabinoid receptors, there must be an endocannabinoid. And then in 1992, this same group identified, actually extracted from the brain and called as anandamide. They found that this material is basically similar to the anand of Sanskrit word. That's why anandamide, and its isomer is a virodamine. When amine is there, it's an amide. Arachidinoyl ethanolamide. And they also found in the pregnant mammals placenta, and also in the brain, the 2 arachidinoyl glycerol. No much difference, but they are basically, they are 2 endocannabinoids which are very popular. Coming to the endocannabinoid receptor system in human body, this is very critical. It's not very technical, but I just like there are two types of cannabinoid receptors, the CB1 and CB2. And why it has got so large plethora of advantages in the medicines, and that is what we are going to look into, because it can, CB1 receptor is basically concentrated mainly in the brain part of it, cerebral part of it. That is why the THC acts on the cerebral part much more actively, and that's why you get the brain buzz and many other things. It has got tremendous value. People are using, and there are more than thousands and thousands of papers are coming on this aspect nowadays. One of the highest sought after area of research. And you can see what are the functions it can do, so many functions it can handle. And the CB2 is basically in the peripheral system, immune system basically. Now, there are papers on the COVID-19 also, because of its immune system, it enhances the immunity like anything, particularly the seeds and leaves enhance the immunity like anything. Now you can see on the right hand side how many parts of the body it can affect. So this is where the large number of applications for the medicines you can use. Now, just to give a little bit of why does it, how this they work, I have the neurotransmission, you can read it. But most important part is in the end, which is red font. EC plays a bigger role in regulating our emotions. I'm talking about the endocannabinoid system, the endocannabinoids, endocannabinoid receptors, which are there. This is the upper side on the right hand side. The first one is the receptor, and then one is the transmitter, and it is slightly different than the normal transmission. That's why I wanted to have it. It is just opposite of the normal transmission of the cell. And those who are interested, we can discuss that later on in the QA. Now, it regulates our emotions, thinking, and behavior. That means actions. They all are chemical based for this one. And the way we feel, that means the way we feel, the way we feel, think, and act. Another very important point, that is the most important part, according to what I feel, reproduction, anandamide and 2-arachidonyl glycerol was found in the mammalian ovarian system and placenta and the reproductive system almost 100 times more than the brain. And that puzzled the scientists. It was really puzzling. What does it mean? Then a lot of research gone into this one, and they realized that it is anandamide oblique 2-arachidonyl glycerol facilitate the early pregnancy. Without them, the pregnancy will not happen. The fertilized egg has got the placental connection only triggered by these chemicals. Otherwise, there won't be any attachment, and this basically facilitates the so-called the first communication between the mother and the child is still not developed. And then it also, most important part is that the babies, those who are particularly on the mouse, the clinical work has been done. Same with the other one also. Newborn babies, and they are put the blocker of these CB1, CB2 receptors, blocker they are given, they could not suckle the milk from the mother. And that is where they could not get the nourishment. And they found that those the newborn babies were given this antagonist, we call it antagonist, or the receptor blockers, could not suckle. They did not have the ability to suckle the milk, and that's why they died. And this is where this is also very, very critical, that until unless and by the way, colostrum, the first milk of the mother, mammalian mother, has got a very large concentration of 2-arachidonyl glycerol and anandamide in it. This is where I think that the people are now debating whether the mammalian development of the mammalians come from this particular cannabinoid receptor systems in the mammals. Now, medical applications. Medical applications of the cannabinoids are basically a large number of things. I don't want to read all these things. You can say that it has an anxiety, means all the psychotropic material, anxiety removal. That's why it gives you the I can discuss that mechanism, but that is not, there is no time for it. Particularly, TC controls the hippocampus. That's why it also gets the memory part of it. Similarly, addiction treatment. Many people have used this for the addiction removal, cocaine or alcohol. Alcohol is also psychotropic material, by the way, just like neuropathic, and it reduces the pain. It's the best natural painkiller known so far. The neuroprotection, because it is an antioxidant, very high antioxidant. Amazingly, it controls and cures migraine. These are, I'm talking about these clinical trial-based research studies. I have around 100 papers and reviews I have cited in my paper, in this one. It also, it's a very useful thing, is the epilepsy or seizures, because CBD, THC, anticonvulsant, AC modulation of the seizures threshold. So it controls that one. On the other parts, there are so many, like rheumatoid arthritis is very well known. Appetite stimulation for people, it is very much known. And there is a drug called Surinabend, and which was basically for the obesity, anti-obesity drug, which was introduced in the Europe because that's a blocker. So they suppress this appetite stimulation blockers, and that's why the appetite was decreased. But then it has also got side effects like suicidal tendencies. Because as you all know, the same part of the brain works for the appetite, for the living, as well as for the reproduction. Now, the biggest thing, and now the whole world is after this oncological, because it is known now, it reduces the tumor very well. And apart from this one, after the chemotherapy aspects, the side effects are also reduced considerably, and neuropathic pain, sclerosis pain, it completely, CBD particularly, and THC, particularly CBD is much more important for this peripheral system. Gastritis, biological solution problems, reproductive problems, premature ejaculation for many people, infertility, because some people have got the less of the anandamide or 2-AG. This is where the fertility comes in, and that's why this is CBD is added, and because that is the same that works on the same receptor. Now, how much time do I have, Gopi?
Yeah, time is over. Your time is over.
Oh my God! But give me some time, because I think it is.
Can you close it, because you can
Cannabis is a
closing remark.
Two, three slides only.
Okay.
Cannabis is a traditional Indian medical system. It has been very well documented, and there are almost 50 different names given in the Ananda Kand, which I have downloaded and got those names. And these names attribute the different applications of the, so at least 44, 45 applications are defined in Ayurveda, our ancient literatures. And they are documented by the Das and Rasso. Rasso is also, Ethano Rasso, very well, it is written
Rajiv, we lost you.
Seems the internet having a problem.
Rajiv, are you there?
Now, I'm just coming to the last few words. This is where the trends I tell you, and you see the okay. So you see the number of papers I have given them in the blocks of the 4 years block, and you see after 2012 the legalization started, and there is a significant jump in the post 2012, 15, and now it is 19. So many papers, reviews, books are coming. It is amazing to see. Similarly, in the patents also, I have come. This is the patent one. We have very comprehensive data on the number of patents on the cannabis or the granted one. It is the same trend. Now, these are the FDA-approved commercial cannabinoid-based drugs available. And these are the companies, you can say, the GW in the UK, and the name is the Sativex or the Nabixolone, And dronabinol is a basically it's a synthetic drug, as I told you. It's a derivative of HU210. THC is the main component. It is used HIV-induced anorexia, chemotherapy-induced. This is where in that one. It is FDA has approved it. Migraine is also, you see, the analgesic migraine. Now coming to CBD is also epilepsy-induced seizures. And then so many syndromes. It is basically anti-inflammatory, and on the right-hand side column, you can see who is the owner of that one. Now, this is where the business is. Last slide or my before conclusion, perhaps. The market size of the legal cannabis is a market report of 2020, and you can see the prediction. Today, in today's world, the legal cannabis or legal marijuana market is around $19 billion US. Global. 85% on the right-hand side you see is by US. And that is where the trick comes. And they have seen the value of it. Now, it is expected that it will, the minimum, I have got 3 reports, the minimum CAGR, the compounded rate of growth is around 18.9%. Which is very high. And you can see it is expected that by 2027, the global market will be 275 billion. And if India, they have also given, if India has what a very large population, India and China, then it will go into 200 to 300 billion dollar business. It's a very big one for a single crop. Now, summary and conclusions. The cannabis, that is bhang or vijaya, a wonder plant, and sub-humidity for many, many years. It was demonized only because of the economic reasons by the Britishers and later on by Americans, again by the same reasons for the alcohol industry. And now I can simply say, the data says that during this COVID-19, when the alcohol in India, as well as in the America and Europe, there is an increase of around 300% sale of this marijuana-based eatables, I will simply say, as well as birds and all those things. It is as legalized as a modern research is paving the way for social acceptance, as well as the resulting the rapidly increasing legalization is giving an impetus for the commercialization, as well as for the patents and publication. India can benefit a great deal with this one because it is a native plant to us. It does not need too much of protection, and it can simply revolutionize agriculture if it is combined with the other crops. Thank you very much for your things. I had to rush certain things, but the material was so it was so exciting to me at least.
Thank you, Raju. Yeah, any question? Briefly, you can have 1 or 2 questions. I think there's one.
Rajiv, it's an excellent talk. I have a couple of questions.
Yeah.
See, this as you said, THC is the psychoactive component which is found both in hemp as well as marijuana. But one is the banned item, and other one hemp. You said it's a legal one. So how do you compare both?
It is. I think I missed that point, or I could not emphasize that. See, in the hemp is defined as if the THC content in the plant is less than plant product is less than 0.3% in USA, as per the legal definition. In India, it is 5%. Anything above that one is marijuana.
Okay.
Same is called. Okay, thank you.
That is what.
And what about the CBD content? Is it legal CBD? Because it is also present in both this thing.
CBD is non-psychotropic, and there is a company called CBD in Bangalore, in India, and there is a huge. There is the TV people are ignorant. This is CBD oil. CBD oil is also basically is a slightly what is called misrepresented. Some people can tell the THC also into CBD oil. That is why it is a problem. That's illegal.
See, another question. See, it is a mixture of almost 500 compounds. Both. It belongs to the same species. But how do you isolate these compounds? CBD.
actually it is so simple to isolate. Any person can do this. First of all, it is an extraction, and then it is separated. The THC and CBD are common. Basically, they need not to separate. There is a pharmacopoeia. There is a whole book on this one, and it is relatively easy to convert CBD and THC also in the laboratory. Very simple. I can do in my kitchen, by the way.
Acha, my last question. Can you comment on spiritual uses of this hemp?
I did not want to. I did not have
We lost
to do that, but I tell you, in the Hemp Commission report, it is very well clear that the sadhus and the sannyasis used for spiritual upliftment also, because it can. And the only thing is that I can simply say it is a dose dependency. If you have to intelligently use it, it is a miracle. If you overdose it, but I tell you, the risk is
like any overdose is bad.
Only thing is that there is not a single report in the world of the overdosing. I'm talking about the death is the ultimate risk.
Okay, thank you.
And ultimate. Now there is not a single report attributed to the cannabis in the world or marijuana. However, there are in 2017 report from the NIH, the American NIH body. Alcohol deaths were 2,272,000 directly attributed to alcohol. Even in India, you can see alcohol kills many more people. Cannabis does not.
Thank you very much, Raju.
Okay, thank you.
I have no problem. I can stay till end. If there are some questions by the people, those people can stay and we can discuss a lot.
Thank you.
Okay, thank you.
Yeah, thank you very much. You give the now. Then we have the next talk is from Ashok Giri, who is from National Chemical Laboratory, the chairman of the Biochemical Sciences Division, and he's going to speak on his recent work, where he has published a lot of publications based on his recent work related to the molecules which are isolated and characterized from his group. Ashok, are you ready?
Yeah, sir. Yeah, just I'm sharing the screen.
Okay, thank you. Yeah, very good. Yeah.
So, do you see my slides?
Yes.
Yes. Yes.
You can make a full screen.
I can see your lab, your building. So,
Okay.
so that means everything is fine. So.
Thank you, Professor Rao, for introducing, and it was very nice to see, nice to hear all three talks, which are very interesting.
Yeah.
So I'm going to talk today something what we did in last couple of months, I will say 4 or 5 months. So battling against COVID, repurposing of therapies. So at the beginning, I wanted to say that also the way other speakers said that I am also not working on COVID anytime. So we work on plant-insect interaction, try to understand how plant defend against insects and pests. You have heard my talk in Kashida on Alfonso. What are the secrets of Alfonso? We work on metabolites of Osimum and several other species of Osimum, as well as exotic plants from Western Ghats like Chiropygia, the beautiful fruits, or flowers, as well as we work on these anti-nutritional compounds from tomato and potato. So sometime back, one of a PhD student joined in my lab in 2010. His name is Rakesh Joshi, and he brought this computational biology in my group. Now I'm happy to inform you that he is now faculty in Biochemical Sciences Division. Like after PhD, he worked 5-6 years in university, and now he is back as a scientist. So he brought this computational biology work in my group to understand molecular interactions between protein, ligand, and so on. And that we thought when there was a lockdown, there was nothing that we can go and work in apps. So we thought let's start working on something on the COVID, that is coronavirus. So it's not something that we are working regularly on this. So I don't have to really talk about this problem of COVID-19. It is every day the deaths are changing, but now as per the today's news, we have almost touching 92,000 people are died, and in one day yesterday it's like 1,141 people died. Of course, there is a lot of news also comes on vaccines and drugs, And just to give you a statistic, vaccines against COVID are in clinical evaluation. 9 vaccines are in phase 3 clinical trials, whereas more than 146 candidate vaccines in preclinical trials. However, there are no drugs or no therapies available yet to mitigate the COVID-19. So I'm sure all of you know also this remdesivir, which is RNA-dependent RNA polymerase inhibitor, which is highly used, and it's, I mean, you hear again every day this news. See the possibilities of using these molecules or structural libraries to screen against the targets of coronavirus, and then optimize the lead and in vitro and in vivo studies. And I'm happy to share with you that the molecules that we identified for repurposing are already in a clinical trial, and that's a very, very good news, by the way. So, how we started this? Basically, what we thought is targeting multiple targets could be a more sustainable strategy. And I think I don't need to mention to this audience that if you target multiple, multiple targets of the virus, it will be actually sustaining for more time. One of the interesting thing is this human angiostatin converting enzyme. This is called AC2, which is actually entry point for the virus. So there is a receptor in the virus, and that's how it enters into the virus. The other is this virus is RNA virus, and all of you know that this RNA-dependent RNA polymerase to replicate. And to process and to maturation, there is something called protease, which is called MPRO, or main protease, which is also so all these three targets, not only for us, we selected these three, but of course for others also, and earlier also, whenever they were developing these antivirals, these were the potential targets. And since the structure was available from the coronavirus, this COVID-19, so we thought this could be a good option to screen these molecules against this. So just to tell you again, this SA2, like human angiostatin converting enzyme 2, is an entry point, and it presents in the lung, heart, and intestinal tissues. And this is a very promising target for the developing the new drugs. As I said, this is a RNA virus. RNA-dependent RNA polymerase is the machinery that amplifies. There are something like 29 proteins in the SARS-CoV-2, and RNA-dependent RNA polymerase plays a crucial role in actually replicating and disease development. So a lot of antivirals were actually developed using this as a target. So of course we use that as a target. And as also mentioned that this protease, which is a papain-like protease, which is very, very important for self-maturations, as well as this processing of viral replicase enzyme. It is actually has two catalytic domain. One is chymotrypsin and another is 3C protease like of interesting thing is, if you see the similarity of this protease with human proteases, there are no similarity. So that's a good target, so that it could be a very specific to the virus, and it will not have any adverse effect on the human if you are using this as a target protease. And if you develop a molecule on the basis of this, it will have very less side effects. So we use these three targets, and before that we thought whether this is a good target. So as all of you know, the origin of this COVID-19 is probably from the bats, but then when we looked clustering of this main proteases in from different viruses, we could see there are 5 clades. Clade 1 is more of a porcine. Clade 2 is avian host, like if you see here, it's like mostly chicken, and the clade 3 is probably from the bat, and that's quite confirmed now it is from the bat. And these proteases actually have very conserved domain. So that means if you develop a molecule against such a nice target, it could have multiple applications. So we have more than 5,000 plus molecule structure library of these molecules, and we added few of them, and we screened something like more than 7,000 molecules. They include several plant metabolites belonging to flavonoids, glucosinolides, anti-tissue compounds, anti-influenza compounds, antiviral compounds, terpenoids, and alkaloids. And several of these phytochemicals were actually showing strong binding to the MPRO, which is a main protease target, as well as the other targets that I was mentioning about. One is this RDRPs, as well as a human angiotensin converting enzyme 2 receptor. So we identified several molecules which showed very promising data, but what I would like to show you, because again, all of you know this remdesivir, which is currently used, and it is quite effective. So the molecules that we screen, and these are like very, I mean, as I mentioned you that in earlier slide, we screen more than 7,000 molecules, but I'm showing here data of only 6 molecules, and we identified a dozen of molecules having much more better score than the remdesivir. So just to tell you this binding energy, that means like how much complex or how much stable complex it forms with this MPRO, that is main proteases, RDRPs, as well as human angiotensin converting enzyme 2 receptors. And this is a combined score. So what we did is, since this HC2 receptor is the entry point, so we scored it like 60% and 20% to MPRO and 20% to RDRPs. And if you see these scores like CAS, this is combined activity score, we identified that these molecules, firstly 3 molecules, myricitrine, for example, delta viniferin and meritylene, these are actually much better than or equivalent to the remdesivir, as well as the antivirals which are known, like for example, ledipalzavir, dacalastavir, as well as soposavir, they are actually equivalent or even higher than the remdesivir. So we thought that time, like this was somewhere between like end of April or beginning of the May, and we were like found it very interesting. We contacted several people who are involved in the drug discovery, and they help us to really do lot of pharmacokinetics and other activities, and they also felt that this is very, very promising candidates, and it has to be go for further in vitro as well as in vivo and clinical trials. So just to give you the background of these molecules which we shortlisted. So for example, delta viniferin is coming from the black grapes, that I mean very common. It is known Ayurvedic anti-tissue medicine. It has strong binding with all the 3 targets, and it is already known that it has antiviral activity. So that also confirms what we were saying is perfectly right. These are the molecules coming from the plants. Similarly, this myricitrine, which is a glycosylated analog of the myricitrine, again, it is present in Myrica esculenta, which is called kaffal plant. It's a typical plant grown in actually northeast area. And also this molecule was known that it has antiviral activity against HIV as well as other viruses. So that means these molecules are able to really help not only for the virus replication, but to the entry of the virus. So we propose this for Ayush, and we are working on it, developing the formulations from these 3 plants, as I mentioned, grape as well as this kaffal plant. And these, I mean, again, as Dr. Rajiv Kumar mentioned, it's not very difficult to extract these molecules because they have very specific properties and they are quite abundant in these specialized plants. Coming back to the known antivirals, so these are the, again, we screen more than 60 known antivirals, and based on these binding scores as well as combined activity score, we've identified 3 molecules which are much better than remdesivir. One is this ledipalzavir as well as dacalastavir, and they could target all the 3 targets like main proteases, RDRPs, as well as human angiotensin converting enzyme 2. And again, we come up with these 2 combination. So for example, ledipalzavir as well as soposavir and dacalastavir as a soposavir. And this combination we propose for the clinical trial. I'm very happy to tell you that this inputs from the clinicians, particularly Dr. Dhruv Chaudhary from Haryana, he came forward when he saw our paper. He contacted us, and then we developed a proposal together with one of the CRO in Pune, in Pirangut, called Intox. So they will be doing toxicity studies of this combination, as well as this medical institute in Rohtak. With the leadership of Dhruv Chaudhary, they will be doing the clinical trials. So, but what I wanted to give you, the message is that these combinations, as far as our calculations are going on, they are much better than or they are going to work very nicely against COVID-19. Another advantage of these molecules is like remdesivir is injectable, whereas both these molecules, or all the three molecules what we identified, they can be given as oral. So that's another advantage to it. So right now the clinical trials are going on. I mean, I cannot reveal the whole data, but what I came to know from our collaborator that this trial started last week, and they are saying that they are very encouraging data. But of course, we have to monitor this for at least 30 days, and then we can really go ahead with this. What I'm trying to say that whatever the expertise were available, and we use this time, and I'm so happy that we could successfully show it. The work that whatever we did on this, it's published in one of the journal in USA, and this till this point, like we have more than 6,000 views, and 17 in last 3 months it has been cited more than 79 times. So that's again the success. Of course, it's a teamwork from CSIR, NCL, Rakesh Joshi and Mahesh Kulkarni were involved, and the students like Shaunak, Sneha, Shiva, Meenakshi, and Vaibhav, they actually were screening and calculating from these data. From Intox, Dr. Narendra Deshmukh and Dr. Anita Ashok, she is having more than 20-year experience in the drug discovery. She helped us to do the pharmacokinetic studies, as well as keeping this combined activity. And based on that only, we proposed to the DBT, which is called BIRAC, and they have funded our project. Of course, PGIMS basically, they will be doing the clinical trial. Dhruv Chaudhary is the lead person, and Dr. Mahesh Gupta, as well as Savita Verma, the clinicians will be doing this study. And with this, I would like to have this mantra that Sarve Bhavantu Sukhani, Sarva Santu Niramaya, Sarve Buddhrani Pashyanta, Sarva Om Shanti Shanti Shanti. Thank you.
Very nice. Very nice. Any questions? You would be happy to answer.
Can I ask something, Ashok?
Yeah, please.
Maybe Ashok, you can stop sharing. Yeah.
Ashok, it's very interesting. I just have one, a comment or something I probably need to clarify myself. So when you say about the drug which is working as with respect to the binding energy, it's a completely static overview. But what about the stability of the drug when it binds with the binding pocket of the particular protein, in this case H2 and so on? So have you checked MD simulations or something like that? I mean, in silico.
No, in silico, we could not do MD simulations, but this Dr. Anita Chog, she worked on the drug discovery, and these molecules are known molecules. So we have a lot of data available about their stability and the binding. So as per her views is concerned, it's going to be much more effective, and it's a very stable complex. So that's what
these are already known molecules.
Exactly. So these molecules are known. Both phytochemicals, they are actually used in the cough syrup and so on. So there is a lot of data available about these molecules. And of course, the drugs which are already used for other, like for example, hepatitis and other viruses. So it is already, the data is available. And she studied all these combinations that how we can, what could be the combination, what could happen when these drugs enter in the human body.
Okay, fine.
So,
yeah.
Ashok,
yes, sir.
That means you are saying it is repurposing the drug. Is it like that?
That's correct.
Yeah.
Okay.
So Ashok, so very nice See, I have a question. See, when you want to repurpose a drug, so a lot of things you can avoid because it is already, you know, you have certain sort of approval, pharmacokinetics, another thing is there. But then here, when have you done, before going into clinical trials, have you done the efficacy of these molecules? I know you would have done a docking studies, right? You would have done a docking, right?
No. So we are, so we have not done, but now we propose, and this is what BIRAC is funding for us, that we would like to do the actual studies on the virus.
Yeah, that's what
that will be done, but for clinical trial. So in parallel, we are doing clinical trial before even.
Okay. So in parallel, you're doing, but then you don't know the pharmacokinetics of these molecules towards actually the actual viral infection. That is to be done, right? And then still they allow you to do clinical trials.
Yeah. So okay. So the molecules that we identified are known antivirals. So the pharmacokinetics and other
pharmacokinetics will be known.
Yeah, so that is known. So on the basis of that, since these antivirals are actually currently used, so based on that, they said that you do these studies in parallel, but we will approve. So 3 weeks back, they approved our clinical trials, and actually clinical trials have started. So that was the reason that they actually, because I mean, if we succeed, this could be a molecule identified at least from India that this combination works.
Hello, can you hear me?
Yes, sir.
Hello.
Yes, sir. Yes, sir.
No, yeah, my question is, does it have to go through all the 3 stages of clinical trials like vaccine, or how does it work?
Yeah.
Okay.
So,
there will be phase 1, phase 2, phase 3 will be there, but then you can jump to clinical trials faster.
That is a bigger jump. Now we are doing with 60 patients, and if we get interesting data, then this will be.
No, but that means infected patients or healthy people.
Infected patients.
Okay, very good.
But you have to do both, I think, control and infected.
Several controls will be there.
Yeah, several controls will be there.
Yes. Nice, thank you very much. Beautiful talk. Any other questions before we close?
So what is the way forward from here? I mean, say DCJ approved this as a fast track and most important, significant, based on the safety profile and repurposing. So what is the perspective? What you are expecting from here in 3 months, 6 months, or a year time?
So right now, the companies who have the license to sell this as a drug, they approached us. And they are saying that we wanted to be a knowledge partner to them. Like, since the licensing and everything is done by them, so we can get patent, but we might not get actually.
So that's my worry, because for repurposing drug, Indian patent law doesn't allow it. Right. So my question was actually who will own the IP for an outcome that what you have been striving for.
So Mylan is the company probably they will be having. But the good part is that we are actually helping them to go ahead and proceed. And they, of course, they approached us based on
Which is the company?
Mylan.
The same thing what they're doing, kit and all that, right? Yeah. MyLab, they got Lonavala,
no, MyLab.
No, Mylan.
MyLab is different.
MyLab, okay.
That is a different one, totally.
So that is, Jayant, you are very right, because we initially contacted our IP group as well as Urdeep, and we realized that selling as a drug is not possible.
There is a question from Archana. ACE2 act as receptor for COVID. Does in previous clinical conditions like diabetes, heart disease, do there is a stronger reception by ACE2?
Yeah, I think there are a lot of studies available. Again, I'm not the expert on this thing, but yes, it is known actually.
Okay.
It is known.
Okay. Yeah. Professor Madhura, maybe we can go to.
Yeah, we know next. Very excellent talk, Ashok.
Thank you.
It's nice. We are doing a lot of work in the lockdown itself. Thank you very much. Now we have very young, youngest perhaps among the all.
Young.
Oh,
yeah.
Krishnamurti is young.
My heart is really young.
I'm sorry. I stand for. Yeah. So the second youngest. So he's CEO from myself, Pune, with the personal relationship. I'm very jolly. I mean, not only very fit. Watson, please go ahead.
Go ahead, Watson.
Before Bachchan start, I just want to say that we are stopping the live streaming in YouTube and also the recording as per Bachchan's request.
Recording, you can stop.
Yeah, I am stopping that. Thank you. You please go ahead.